Back third graders, we have the final book in our series study titled A Rock is Lively. Again, the illustrations are done with watercolor and ink. It is written by our familiar author Diana Hutz Aston and illustrated by, again, Sylvia Long. The book is full of realistic details. The illustrations on each page are very interesting, and it's introducing you to a diversity and a complexity of our natural world about rocks. I have done a series of wonders and notices as I read through the book, so I will stop and point some of those out. And here we go. A rock is lively. Again, personification. Is a rock really lively? It's adding personal or human-like characteristics to unhuman things. On the front, we have malachite, peridot, silver, sandstone, turquoise, amethyst, gold, snowflake, obsidian to start us off. Again, this is expository nonfiction, meaning that it's providing facts and information about rocks. It also has many nonfiction characteristics, character traits, labeling, illustrations, and diagrams. And here we go with our endnotes again. I think that this has something to do with rocks, and we'll probably explore that as we get a little deeper in. We have a gallery here. Remember what a gallery is. We've heard of that before. It's a place, a room, a building that displays works of art. The pictures are not labeled, however. I wonder why. I'm noticing differences between the rocks, different colors, sizes, shapes, textures, lengths. Some you can possibly see through, some that look sharp, but none of them are labeled, which is interesting. And if we were an illustrator, why would we not label our work? So I want you to think of that as we go through. And here we go. A rock is lively. And here is our azurite geode, and it looks as though this page is a zoomed in picture of magnification of inside our geode. A rock is lively. And here we have a piece of snowflake obsidian. Let's see if I can't get more in our picture. There we go. A rock is lively. Bubbling like a pot of soup deep beneath the earth's crust, liquid, molten, boiling. And our caption tells us over here, depending on what type of rock it is, a rock melts at temperatures between 1,300 and 2,400 degrees Fahrenheit. A rock is mixed up. All rocks are made of mixed ingredients called minerals, just as batter of flour, butter, and sugar make a cookie, a batter of minerals makes a rock. The recipe for a rock might include minerals like aluminum, copper, diamond, fluorite, gold, gypsum, lead, nickel, platinum, quartz, silver, sulfur, tin, topaz, turquoise. And over on this side, it looks like a recipe card for lapis lazuli. It's mixing the mineral of lazurite with a dash of sodalite and a pinch of both calcite and pyrite. Heat within the earth until a brilliant blue. So it's interesting that the author has compared rocks to a pot of soup on the previous page, and on this page, making a cookie. Have you ever thought of rocks that way? Rocks are being made. I also find it interesting the way the author has listed in the recipe, all of the minerals in the recipe are alphabetical, listed alphabetically, from aluminum to copper, all the way down to sulfur, tin, topaz. A rock is galactic. Outer space is a shower of rock fireworks. Over here we have meteoroids. That's the example. They're rocks that range in size from a grain of sand to a basketball. They become meteors or shooting stars when they streak through the Earth's atmosphere and vaporize. Sometimes pieces of the meteor aren't vaporized and they land on the Earth's surface, and when that happens, they're called meteorites. Here's a comet and a picture of a comet. Comets are balls of rice. I'm sorry. Comets are balls of rock and ice, sometimes called dirty snowballs. They are heated by the sun and soar through space, leaving glowing ribbons of dust behind them. Down here we have asteroids, and here's our big asteroid on the side. Asteroids are gigantic chunks of rocks and metal. They can weigh millions of tons. The largest known asteroid is 650 miles in diameter, so that's the width of it, the diameter. It would take a person 352 hours or nearly 15 days to walk around it. A rock is old. The oldest known rocks on Earth were formed billions of years before the sky turned from green to blue, before dinosaurs thundered across the Earth, before humans learned how to make fire. The oldest rocks ever found are nearly 4.5 billion years old. And here we have, similar to a timeline, we have a meteorite fragment from Algeria that's 4.4 billion years old. We have greenstone from Canada at 4.28 billion years old. Up here, this little one under magnification is zircon crystal from Australia. That's 4.1 billion years old. We have the Louisian, from Scotland is 3 billion years old. And then take a picture of this, a peek at this granite. We're known as the granite state. So granite from the United States, 2.5 billion years old. I find it interesting how this is organized, this timeline from oldest to youngest, right? Just like when you did the Kate Sessions timeline, you started when she was born and you went all the way through her death. And that's what they've done here with these rocks, organize them in order of oldest to youngest. A rock is huge. Considered by many to be the world's largest rock, Australia's Mount Augustus is a sandstone rock with an elevation or height of 3,628 feet above sea level. That's about 1,000 feet higher than the world's tallest skyscraper. So a rock can be huge or tiny. The carpets of sand on the floors and shores of the oceans, lakes, and rivers come from larger rocks that have been ground through weathering into tiny rocks. So the weather is washing away pieces of the rock and turns it into small pebbles. A rock is helpful. Some birds swallow stones to help them digest food. As the muscles in the gizzard of the stomach move, food is chewed, crushed by rock in the same way that humans use teeth to break down food. Crocodiles, seals, and sea lions also ingest rocks. The extra weight or ballast helps them dive deeper and stay steady in water. So the extra weight is called the ballast that helps them sink down. Sea otters lie on their backs and use rocks to crack open shells on their stomachs. Seagulls drop mollusks onto rocks to break apart their shells. Chimpanzees and crows crack the hard shells of nuts onto rocks. So very helpful. A rock is surprising. How is a rock surprising? Well, some rocks need to be broken open to reveal their beauty. Geodes, round, hollow rocks found mostly in deserts or beds of volcanic ash, hide sparkly crystals. The crystals were once liquid, but trapped inside rocks for thousands of years, they changed into jewels of many colors. Agates, too, with their colorful layers created by liquid deposits, are often found in volcanic rock. A rock is inventive. Long ago, humans chiseled rocks into sharp-edged weapons and tools. Flaky flint and obsidian rocks were chipped into arrowheads, spear points, axes, and hammers. Rough granite, sandstone, and lava rocks were shaped into mortars and pestles used for grinding seeds, rice, nuts, chilies, and garlic into food. And here we have a mortar and pestle from Greece, and that ball is used to grind around to break things up. And up here we have, let's see, our labels tell us we have a hammer from France, we have an axe head from England, an arrowhead from the United States, a spear point from Africa, and right here is a knife from the United States. Today, humans use rock to make cement and bricks, paper and pencils, glass and toothpaste. And we have graphite, quartz, and limestone labeled in our picture here. A rock is creative. 10,000 years ago, before there was writing, ancient peoples told stories through symbols. With colors made from minerals, they painted pictographs on cave walls, rocks, shelters, and ledges. They chipped and pecked the surfaces of sandstones. They chipped and pecked the surface of stones to make petroglyphs. So down here on the bottom of the first page, our label is telling us that this is a pictograph from Lascaux, France, 12,000 to 17,000 years old. Okay, and then over on this page we have a petroglyph, and this is from 9 Mile Canyon in Utah. It's about 1,000 years old. So pictographs are painted onto rocks and petroglyphs are carved into them. And I'm just surprised how very long they last. 1,000 years and over 12,000 years. Up here, the illustrator and the author have worked together to give us a list of some of the minerals that would help do the petroglyphs and primarily the pictographs. We've got chalk, limonite, hematite, limonite, hematite, and manganese to give you the colors. In more recent history, artists and builders have chiseled great sculptures from monuments from all kinds of rock. Here we have limestone, and that was chiseled away to make the pyramids of Giza in Egypt. They're between 4,100 and 4,600 years old. We have basalt and other volcanic rocks to make these Easter Island, these famous faces. That's also in one of our virtual tours. Down here we have sandstone, dolerite, and others that made Stonehenge in England, 3,100 to 5,100 years old. Amazing. On this page, some of our images are labeled with captions. We've got our marble rock, which is which the Taj Mahal is made out of in India. That's about 400 years old. Onyx, this carving of mother and child by Isamu Noguchi in the United States. That's only about 60 years old, rather young compared to some of these others. Right here, marble. The David was carved out of marble by Michelangelo in Italy. That's about 500 years old. And finally, we have granite, Mount Rushmore in the United States. That's almost 100 years old, but the faces of our presidents are carved in. A rock is recycled. Sedimentary rocks like coal and limestone have eroded over time into smaller pieces of sand, pebbles, and gravel, and then were pressed together like a layer cake with fossils, seashells, and decayed plants. Secondly, we have metamorphic rock. Rocks that began as sedimentary or igneous, but were baked and squeezed so hard by heat and pressure that they became metamorphic rock. And examples are slate and marble. Finally, we have the igneous rock. These are rocks that are formed by magma. So when magma erupts through volcanoes, it cools and hardens into rocks like granite and pumice. Pumice is so lightweight that it actually floats. And you may have heard of a pumice stone, perhaps. People use those to get rid of some of the old dead skin on their hands and feet. A rock doesn't hurry. Over thousands of millions of years, it changes from one form to another. This is called the rock cycle. It's in a process called erosion. A rock is squashed and scraped by glaciers, whirled by waves and rain, and pushed deep into the earth until it turns into magma. Then a rock is once again alive and lively. And this is obsidian bursting out of a volcano. What's very interesting is, how did our story start? Do you remember? Our book started with snowflake obsidian and a rock is lively. We've gone through the rock cycle and all sorts of rock discussions. And again, our rock is lively, but this time it's bursting out of a volcano. We end with another peek at the gallery. And this time our gallery has labels to go along with our rocks. So why do you think the author and illustrator did not label our gallery at the beginning but labeled at the end? We've learned a lot about rocks, and maybe they're now showing us the names because we have learned so much about them. Now we're a little more interested. We have some background, we have some schema on rocks. And it ends once again with the magnification of what we believe is to be a geode, a zoomed in geode image. All right, thanks guys.